Hi everybody, part 2 on chapter 9, climate change. One of the most important things that I want to do in talking to you is make sure that you understand the difference between the natural causes of climate change on Earth, and that climate change has always happened since Earth's been in existence, and the anthropogenic activities that are increasing rapid changes in climate and temperature that we can measure and observe happening now during our lifetimes. So it's really important to be able to see that temperature of Earth's atmosphere is affected by the amount of solar radiation we're receiving. It can be tied into some sunspot cycles. People study that. Definitely the amount of solar incoming radiation determines how our atmosphere is in its average temperature, and Earth's orbit, the Milankovitch cycles. Hopefully you've watched those videos. And that determines the differences in the amount of heat that's coming into our atmosphere. But something that affects our atmosphere that is not a natural cause is human influences, and human activities can affect the atmosphere, and it can affect what is the natural greenhouse effect, which we'll talk about in a minute. So in chapter 3, we talked about what the atmosphere is made of. So you might want to go back to chapter 3, mostly nitrogen, 78%, oxygen, 21%, and trace gases. It's these trace gases that make a big difference. And these trace gases are carbon dioxide, methane, nitrous oxide. There are other trace gases as well. But these three gases absorb a disproportionate amount of light energy coming into the Earth and being radiated back, and they trap it as heat. Sorry, it says here, but it meant to say heat. This is a good video to watch, I think, for you to be able to understand that. So one of the things I want to make sure that you understand, and it didn't seem like you got this from watching How Do Greenhouse Gases Really Work, is the Earth has a natural greenhouse effect. And this natural greenhouse effect happens because of the incoming radiation that comes into the Earth. And about 30% of that is reflected back out through clouds and the surface of the Earth. But of the 70% that comes in, it is then re-radiated back out into space, and it is re-radiated back out into our atmosphere. Our atmosphere traps the heat from Earth, and it is our blanket. The ozone is our sunscreen. The ozone is separate from greenhouse effects. The greenhouse effect, the natural greenhouse effect, is what makes life possible on Earth, not on the moon. The moon is boiling at some times during the lunar day and freezing at other times during the lunar day. That doesn't happen on Earth. We have some variation in daily temperatures. In the desert, we have a lot of variation, sometimes 30, 35 degrees at a high and a low, but variations in temperature on Earth don't swing in the hundreds of degrees. And that is because we have an atmosphere. The atmosphere absorbs heat that's being radiated out from the Earth back into space, and it traps it. And that blanket is what keeps us warm, and it moderates the climate on Earth, and it makes life possible. The ozone layer meant that when Earth existed and there was only life in the ocean, that once we have an ozone layer, life could come out of the ocean because we would no longer be killed by UV radiation. The ozone is our sunscreen, the atmosphere is our blanket, and it has a natural greenhouse effect. What anthropogenic activities are doing are turning up the thermostat on that blanket on Earth. And we're making the blanket on Earth be warmer, and it's holding more heat in. So when that happens, we actually have greenhouse gases, naturally occurring greenhouse gases, which are water vapor, carbon dioxide, methane, and nitrous oxide. And they occur naturally in our environment. Water vapor is the most abundant naturally occurring gas. Human beings cannot affect water vapor in the atmosphere very much to any significant degree, but we can affect carbon dioxide, methane, nitrous oxide. And human activities, anthropogenic activities, have impacted the atmosphere by cutting down trees, deforestation. We did that for agriculture, we've done that for grazing, we've done that for building homes, we've done that for many, many, many generations, hundreds of years. We have cut down trees. And that is taking away the ability of Earth to remove carbon dioxide from the atmosphere and put oxygen back into it. So that is something that is increasing CO2 in the atmosphere. And we're burning fossil fuels. Fossil fuels are long-term carbon storage. We have microorganisms in the ocean that sink, that get buried for hundreds to millions of years, hundreds of millions of years. They turn into petroleum. Dinosaurs don't usually turn into petroleum. But you know what? When you have land and you have lots of plants, the Carboniferous period, and you have those plants buried, that turns into coal. So those are fossil fuels. They're made out of fossilized organisms, whether plant or animal. And when we burn them and use them, we are taking long-term carbon that's been stored in the earth, longer than a tree, and we're putting it back into the atmosphere. And that's something that we're doing to increase the amount of CO2 in the atmosphere. We also are putting some synthetic greenhouse gases in, and that is hydrofluorocarbon compounds, and they replaced chlorofluorocarbons. I don't want you to confuse these. CFCs are what cause the hole in the ozone. They are not a greenhouse gas. The replacement for CFCs are hydrofluorocarbons, and they are a greenhouse gas. And because of this, these activities, we have, since the Industrial Revolution, we have increased the amount of CO2 in the atmosphere by a dramatic amount. The Keeling curve is something you should go back into your book and you should study what the Keeling curve means and its measurements, its actual physical measurements of parts per million of carbon in our atmosphere. We've also been able to measure other greenhouse gases. What are the 3 greenhouse gases that humans can affect? CO2, nitrous oxide, and methane. And these are the actual measurements of what's happened since 1975. And you can see definite increases. Some of them are measured in parts per million. Some are measured in other degrees, for sure, parts per billion. So where do the greenhouse gases come from? They come from human activity. And this human activity, we express it and it measured in carbon dioxide equivalent, CO2 equivalent. Again, go back into the PowerPoint, go back into your e-text to understand what CO2 equivalents mean. We have to be able to measure how much is 1 molecule of methane able to do versus 1 molecule of CO2. And methane is far worse in our atmosphere, even though it doesn't stay there as long, because its CO2 equivalent is much greater. It can absorb much more heat in the time that it's in the atmosphere versus what CO2 can do. So every molecule of methane we put up there is worse than 100 molecules or 1,000 molecules of CO2. So burning fossil fuels, we do that by generating electricity, we do that by transportation, we do it in industrial processes. Concrete is a huge producer of CO2 equivalents. Agriculture, livestock, and fertilizers definitely produce CO2 equivalents. And you have to look at the difference between industrial and developing countries as to what is put up there. Where do greenhouse gases come from? Well, you can see that the yellow is land use and agriculture. Electricity and heat production is right here. So those are about the same, electricity and heat and land and agriculture. And look over here, this is industry and this is transportation. So if you change your diet, if we produce less methane, if we use less fossil fuel when we produce electricity and heat production, these 2 things can change much more about greenhouse gases in our atmosphere than what kind of car you drive. I don't want to say don't drive a fuel-efficient car or even think about a hybrid, but if you change your behavior and your diet and how we produce electricity and how much electricity we use, that will make a bigger difference in reducing greenhouse gases than the kind of transportation that we have. And then you can look at the differences in how the world emits CO2, Brazil and New Zealand. You can look at the differences here, but you can also see in this one that the United States has actually decreased in the per capita CO2 emissions. So some of the things that we are doing are helping. What we've done in the past has helped because this went up to 2013, right? There's been some changes in the last 7 years that might have reversed that, especially the current administration, which has relaxed some of those. But you can also see that China has greatly increased their per capita CO2 emissions. And that happens as you get developed countries going. The consequences of global warming, and this is where we talk about the difference between climate change and global warming. Climate change is long-term patterns of temperature and precipitation that change actual biomes, change where organisms live. Global warming refers to a rapid increase in the temperatures that we are observing in the ocean and in the air. And we have those measurements going back from physical data that human beings have measured for global air temperatures and sea temperatures. Your chapter talks about that earlier on. And we have something called proxy data, which you should also read about. And that's what we use the marine sediments and the ice core data for. We weren't here 200,000 years ago measuring it. We weren't here 800,000 years ago measuring it. But we can look at the things in those ice cores and the marine sediment to tell us what the temperature was, what the climate was, and we can also measure CO2 and methane in those cores as well. What are the consequences of rapidly increasing temperatures on Earth? And that's what global warming is. We can see climate patterns changing. We can see droughts. We can see floods. How does it impact ecosystems and biomes? We have more intense storms. We have ice sheets and glaciers that are melting. And ice sheets and glaciers mean that you are looking at ice that is on land. It's not in the water. So when you melt ice on land and it gets into the water, it does two things. One is it removes white from the surface of the Earth, less reflectivity, lower albedo, right? So we're not reflecting as much heat back. If you watch the Milankovitch videos, you'll understand this. And number two, we are putting more water into the ocean. So we are raising the sea level. And the other thing that happens is you have rising sea levels not only due to meltwater from glaciers, but when you heat water up, we've talked about this, when you heat up a mug of water in your microwave, it expands. And so warm water takes up more room. And thermal expansion is what's causing 50% of the rise of sea level that we're observing right now. So these are consequences of rapidly changing temperatures on Earth, global warming, and more severe storms, not more storms, but more severe storms, and changing populations and ecosystems, which is a huge thing that we understand more because we've studied communities, biodiversity, when you change ecosystems, when you change biomes, when you change the cues for animal migration and plant physiology, you are affecting both terrestrial and aquatic systems. So that is part 2. I will do a quick part 3 so we can finish up this chapter, but I hope this is helpful.